Okay, we're gonna have a look at fermentation for biology unit 2. Now, for fermentation, it's still a part of respiration. So we know that for respiration, we actually take glucose, as we see here. We take that glucose and we're gonna be creating energy from it. So we know that the glucose goes through glycolysis here. Then it goes through the Krebs cycle. Well, technically, the Krebs cycle after that link reaction, right? And then to the ETC. So let's put the link reaction at 2. Then to the ETC, right? Then, well, which is at 4, right? And that's how it really goes through. But the Krebs cycle, although it isn't inherently an aerobic process, it generally won't happen without oxygen. The body won't allow us to create so much electron carriers and go and have these electron carriers going into the ETC, right, without any oxygen present, as we look at the electron transport chain. So if we don't have any oxygen, right, we go through two types of fermentation. This is lactic acid fermentation. Usually occurs in animals. It is anaerobic. All fermentation is anaerobic. Produces lactic acid, right? And this lactic acid is what creates that burning sensation and muscle fatigue to like athletes. So when the muscles are working hard, right? For example, in general athletics, the great example that Caribbean persons normally use are track athletes when they run, right? Their muscles are using up so much ATP and it's consuming so much oxygen that the muscles get oxygen deprived and start to switch over to lactic acid fermentation and creates this fatigue, right? The body tries to compensate by breathing in a lot of oxygen, start to hyperventilate to replenish oxygen levels, right? And lactic acid is what we find in stuff like spoiled milk and stuff like that. And it often can be used to create stuff like yogurts, right? But I think it would be inhumane to use like human lactic acid or their lactic acid created in humans. So yeah, so we're gonna have that there. So let's look at the process. So with lactic acid fermentation, with all fermentation, we know that glycolysis occurs first. So here we see glycolysis happening, creating pyruvate, right? Remember, it is 2 molecules of pyruvate. Hold on, page switch for a second. 2 molecules of pyruvate, right? And this will produce, well, it's actually 2 NADs, produces 2 NADHs. I know the H looks a bit weird. So we're gonna have these being created. Right? So after the pyruvate is created, then we notice that we're gonna have an enzyme, lactic acid dehydrogenase, working on pyruvate. And it creates 2 moles of lactic acid, right? And it replenishes NAD. Now remember, in fermentation there are always two processes. There's glycolysis, then NAD regeneration, because NAD is required for glycolysis to occur. So it's an entire cycle. As we regenerate the NAD here, right? This is NAD regeneration. As we regenerate the NAD, right? So NAD regeneration. So as we regenerate it, it goes back to glycolysis and starts the process all over. And glycolysis creates a net of 2 ATP. We know that it creates actually 4, but in the energy investment stage, we use up 2. So overall, 2 ATP is produced, right? And this actually helps the muscles or helps the body continue some amount of energy production, but it's really low and really inefficient. Because once we start to create lactic acid, it starts muscle fatigue. It starts to, it starts to mess with the muscle, right? And mess with the cells, the pH of the cells too, right? and it produces so little ATP that the body can only survive for so long, right? And this isn't within most animals, right? So that is that. The enzyme that governs it is lactic acid dehydrogenase. But for ethanol fermentation now, this usually happens in plants and fungi. The fungi that we normally know goes through this, or that we use normally on an industrial level too, is yeast. So it produces ethanol, and it can be used for wine production, beer production, breads, and biofuels. So in biofuels, you can look at transesterification to create different biofuels. That's chemistry unit 2, right? But we have this here. So we have the creation of all of these different things through ethanol fermentation, right? So in ethanol fermentation, this is the process. So same glycolysis, right? But here now, we have something different. The enzyme that governs ethanol fermentation is alcohol dehydrogenase. So it actually decarboxylates the group. So it releases carbon dioxide and produces ethanol. So this is why yeast is used in bread, right? Because the carbon dioxide will actually rise within the dough mixture and leave those air pockets, right? So it creates a really aerated and fluffy pastry or bread or cake, whatever you want, right? And it also allows for the carbonation of some types of beverages, right? And as we know, the ethanol content, right, will increase the alcohol content within the beverage. So the ethanol that is created is going to create that alcohol, right? Because it's an ethanol, right? Ethanols are alcohols. It's going to create that alcohol content. So it's the same thing. We produce NAD, right, for it to be reused up here. Don't make any mistake. Almost everything produced here is the number 2. So I noticed that, except for one carbon dioxide, right? So everything else is going to be produced 2 moles each, right? 2 moles of everything is gonna be produced, and this NAD is gonna find its way back up here. So remember, fermentation always has 2 processes, right? It goes through glycolysis first, then NAD regeneration, right? So lactic acid fermentation happens in the presence of lactic acid dehydrogenase here, and it produces NAD, right? And it goes back to glucose to go through glycolysis, right? Or it goes back to the process of glycolysis, right? And it regenerates pyruvate, and the process starts all over again, right? But here, the difference between that now is that occurs in animals. Here, ethanol fermentation occurs in plants and fungi, notably yeasts, right? So we're gonna have the same thing, glycolysis and NAD regeneration. The NAD goes back to glycolysis to repeat the cycle, right? To produce a little ATP and produce a pyruvate, so the entire cycle can happen over and over again. But here now, we have carbon dioxide being produced. Really important to note. And this process is governed by the enzyme alcohol dehydrogenase, right? So that would be that. So if there's anything I missed, please leave something and please leave a comment, right? Yeah, so that should be good.